In this context, we will discuss the principles of the design of programming languages that are adhered to by assembly languages and those that support the development of viruses. The possibility of creating procedures and functions in assembly languages indeed aids in the development of viruses, since statements that pertain to a particular activity in the virus can be grouped together. This adheres to the abstraction principle, which states that a programming language should avoid requiring something to be stated more than once and to factor out the recurring pattern. Regularity in assembly languages is maintained, which is clearly distinguishable by the fact that there are not many rules or exceptions that the programmer has to remember when coding, and thereby aids in virus programming just as much as it aids other non-virus programming. The syntaxes are simple, easy to understand and learn, and do not consist of too many complex functionalities. This depicts the adherence to the regularity principle. The simple structure of assembly languages keeps well with the simplicity principle, since it contains a minimum number of concepts and very simple rules for their combinations. The static structure of a program written in an assembly language corresponds to its dynamic structure mainly due to its nearness to the machine and computer hardware. This illustrates the adherence of assembly languages to the structure principle, which states that the static structure of the program should correspond in a simple way to the dynamic structure of the corresponding computations. The ability to determine the dynamic structure of a virus by looking at its static structure aids the development of viruses significantly.
Moving on to high-level language tools to develop computer viruses. We do know that a high-level programming language is a programming language with strong abstraction from the details of the computer. In comparison to low-level programming languages, it uses natural language elements, are easier to use, and are more portable across platforms. Such languages hide details of the CPU operations such as memory access models and management of scope. This great abstraction is generally intended to make the language more user-friendly, as it includes concepts from the problem domain instead of those of the machine used. A high-level programming language isolates the execution semantics of computer architecture from the specification of the program, making the process of developing a program simpler and more understandable with respect to a low-level language. In this framework, we take Java as an example programming language that is used to develop computer viruses. Java is a language that was developed mainly to allow portability across different platforms. It was developed based on the idea that the software should run on different kinds of computers, consumer gadgets, and other devices. This is facilitated by the type of file that is used to distribute a Java program. Java code is compiled into bytecode, which is then interpreted before execution on the relevant platform. Programs written in Java have one or two forms, applications or applets. Java applications are like applications written in C or Pascal or BASIC and can do the things that you would expect applications to do. A Java application can perform operations that could compromise security. Java applets are different in that they are run by another application such as a web browser, which is responsible for executing them in a secure environment, often called a sandbox. When running in this sandbox, any Java operations which might compromise security are disallowed, in theory, at any rate. Broadly stating, applets are secure, applications may not be. When one visits a Java-enabled website, you are downloading and running applets. For an example, the Strange Brew virus affects only Java applications, not applets running inside a browser. The Java virtual machine has inbuilt security measures such as not allowing applets to access the hard disk or modifying applications. Netcat is an incredibly simple yet powerful Unix utility which can read and write data over networks using the TCP or UDP protocols. Among its many capabilities is port scanning, the act of probing networks for potentially vulnerable services. Using Java, it is a simple matter for any user to run an application which creates a server socket that binds to a port and listens for inbound connections. But let the user beware. Tools like Netcat can be used to find, attack and overpower even sophisticated network applications. As a simple test, a typical server-socket application was set up and used netcat first to locate and then to host it. Users who set up network applications for whatever reason should be prepared to handle such assaults and attempted break-ins. In this case, it was a naive Java application that fell prey to a non-Java tool, but a utility like netcat could readily be written in Java and deployed for information warfare. One characteristic of Java is its portability, which means the computer programs written in the Java language must run similarly on any supported hardware or operating system platforms. One should be able to write a program once, compile it once, and run it anywhere. This is achieved by compiling the Java language code not to machine code but to Java bytecode, instructions analogous to machine code but intended to be interpreted by a virtual machine written specifically for the host hardware. End users commonly use a Java runtime environment installed on their own machine for standalone Java applications or in a web browser for Java applets. We see that Java adheres to the portability principle, aiding the spread of viruses. The portability principle states that one must avoid features or facilities that are dependent on a particular computer or small group of computers. The development of viruses on Java are exemplified by two very famous viruses, dupe.java and homer.java. Dupe.java was written to illustrate that viruses could indeed be written in Java. To test the application, one simply has to compile it, then move the resulting dupe.class file to a favorite directory to avoid overwriting the original source code, and then run the application from that directory. This generates a perfect copy of the source code directly from the class file. To illustrate the potential for Java applications to act as Trojan horses, an author first wrote a simple Bourne shell script virus which would work on almost any Unix platform. The virus homer.sh echoes Java is safe and Unix viruses do not exist, and then proceeds to append a copy of itself to all non-infected Bourne shell scripts in the victim user's home directory. The author then wrote a little Java application, homer.java, which, when inadvertently run by a user, generates a copy of homer.sh and executes it, thereby infecting the unfortunate user with a Unix virus. It is entirely possible for Java to provide the mechanisms for transmitting viruses, and the possibility of the Java platform virus cannot be dismissed out of hand. A scripting language is a programming language that allows some control of a single or many software applications. Programs written using programming languages, on the other hand, execute independently from other applications. Scripting languages are distinct from the core code of the application, which is usually written using different language, and by being accessible to the end users, they enable the behavior of the application to be adapted to the user's needs.
An Austrian group of virus writers have published a new proof-of-concept malware code that targets Microsoft's forthcoming Windows PowerShell technology. This malware does not exploit any vulnerability in the scripting tool itself. Instead, it is similar to batch-type viruses written in Visual Basic that instruct a system to install malware after a user executes the script. But PowerShell malware poses an increased risk over other batch-based threats because enterprises currently do not block PowerShell scripts on their network. Malware authors could also be attracted to the tool because it offers them with a new challenge.